We are live.
Yes, we're live. Hello, everyone out there. Oh, I've got to mute myself on the Twitch. This is what happens when you're live, everybody. Anyway, welcome to our premiere, our inaugural, #1 with a bullet, Spring Reactive with Josh Long on Tanzu Tuesdays. You can say Tanzu. I've heard it both ways. We're very excited to have Josh Long with us.
What's going on?
I don't know, Josh. We pushed a live stream button, and you and I are in the same Zoom chat room. And I was hoping personally that you could maybe share with us some amazing reactive information via the Spring world. Is that like something you could do?
Am I the only one who's hearing everything twice?
Because you're a Twitch. I just had to do that. Your Twitch is on. You got to mute that. You got to mute Twitch. This is what happens when we're live. It's all real. It's all happening.
Terrifying. I want to go back to bed. This is nuts.
There's Tiffany, everybody. I want to introduce the team. So I'm Bob Brinley. I'm going to host as many of these as I can. But if there's any reason why I can't, we got Tiffany Jernigan here.
Hi.
And then we also have Paul Charkovsky.
Hi.
Say hello. There he is. And
one day, Bob, you'll get co-workers whose names are actually easy to pronounce.
Nah, Jernigan, Charkovsky, potato. All my coworkers are my wife and kids, by the way, because I, like everyone else, is working from home. But anyway, so yeah, we're enough for Emily. We're very excited to invite you all into this Tanzu Tuesday experience where we're going to have developers and just different people talking about all things in kind of our Tanzu portfolio. Again, today is Spring. We're going to be talking about reactive stuff with Josh Long. And so real quick, I want to get to know the developer, Josh. Joshua, is that your full first name?
Yep. So my mom says.
Okay. So Josh, when did you start?
Josh.
When did you start programming? When would you? What was it?
In my teens, I was not very good, and that has continued to this day. So thanks for rubbing it in, you insensitive clod.
Well, if you don't do something well, do it really unwell. I don't know. That way people don't expect results.
Yeah.
So I'm glad that we have you as our first person. All right. So sadly, we're all working from home right now. There's something happening in this world. But if you could be anywhere in the world right now besides your house, where would you be?
Me?
Yes, you, Josh.
Oh dear.
Because you've traveled this great wide world and then some.
I used to get around. That was cool. Last year was it has been such a weird year. Last year was 650,000 miles. Now it's like, a few thousand this whole year, 2020. That's it. It's been so weird. And even if you account for all the miles I've done within my own little tiny San Francisco condo, it's just nothing. I can't believe.
Yeah. Well, I know you speak French fluently. So
learning Chinese.
Very excellent. That's a very good language to learn. So
Mandarin
or Cantonese?
Mandarin. That's the one that's most valuable, but they're all valuable eventually.
Yes,
in terms of numbers I can engage with.
And to round off our last question of get to know your developer, what's your favorite food?
I've been a spam musubi. That's like universally great.
Musubi,
Can't screw that up.
That meme going around of they made the first batch of spam in 1939, and they're about to have to make the second batch. Is very funny. It's now tickled my funny. All right, well that's enough of me. And Josh, again, we thank you so much for joining us. You are an amazing developer advocate for Spring, and we cannot wait to hear your words of wisdom. And without further ado, I bid you.
Thanks, buddy. Adieu, Bob. Thanks. I am a developer advocate for an amazing Spring. That's the way to think about it, right? Spring is pretty legit. And I am very happy to be here with you all today. I'm going to share my screen if that's all right with Bob and the rest. All right. Looks like they muted themselves. That means that they're trusting me not to screw this up. Spotlight's on me. Oh, dear. All right. So We don't have a lot of time, my friends. As always, we have very little time and so much to cover. So I encourage you to, if you're going to do one thing today, take note of this slide here. You're going to find the code for the talk, and you'll find my coordinates. So should you have questions, when ineluctably you have questions, don't hesitate to reach out to me on Twitter. There are my coordinates on email. I much prefer email. I'm sorry, I much prefer Twitter, but email works just fine. I've had to soften my position on email over the years. Those of you who know me know that I'm a fervent anti-Slack fan. Rather, I enjoy not liking Slack, but it's been pretty useful in the COVID crisis, so that's been kind of nice. I've had to run 3 extra computers to be able to support the CPU demand, but it's working. It's nice. Now, code. If you have questions, you can find me there. But if you want to see the code, you want to follow along at home, feel free, be my guest. There's the code, there's the coordinates there. A little bit about myself. Bob just did an amazing job introducing me, so I really don't feel like there's much to add, but my name is Josh. I'm a developer advocate on the Spring team. I have been since 2010. I do training videos. A lot of these are available right now on Safari. You can find the 2 new ones, Reactive Spring Boot 2nd edition and the Spring Boot and Kotlin ones. Those are going live, if not already, then very soon. I've got a book called Cloud Native Java, all about how to build applications that survive and thrive in the cloud in terms of Spring Boot, Spring Cloud, and Cloud Foundry. And of course, I do a podcast every Friday where I talk to people that are smarter than I am. That's a very low bar, mind you, but nonetheless, some very impressive people. The latest episode was the one, the only, the illustrious, the amazing, the inspiring, and fellow cloud native Joe Beda, co-founder of Kubernetes. Really good episode, despite your humble host. He was inspiring and educational and just all around great. So listen to that every Friday and every Tuesday. That's today for those of you not keeping track. Every Tuesday I publish a blog called This Week in Spring that went out last night around midnight. It's just me recounting all the stuff that's fit to reprint, with apologies to the New York Times, from all around the ecosystem. So it's just, all the stuff that that is interesting and of note in the ecosystem. And I've been doing this since 2011. And of course, every Wednesday, I publish a Spring Tips video, which is just me at a keyboard exploring some ecosystem of the Spring, Spring wide world of Springdom, right? A lot of different pieces of arcana there. These videos are deep dives, as opposed to talks like the one you're about to watch, which are more, breadth before depth, right? I care about the roving tour of the ecosystem in these kinds of talks, but there in the Spring Tips videos, I can afford to, double click and look at some details. And I just put out the latest episode on that as well, introducing, among other things, the Kotlin Spring Integration DSL. So go check that out. There's a playlist URL there for for those who are interested. And of course, I'm working on a book called Reactive Spring, and that, my friends, is available for you. If you want to go buy it now, you can. You can read it now, but it's not quite done. If you buy it now, you're entitled to the final edition and all intermediate updates, of course. Now, the book is basically the larger, longer form version of what we're going to talk about in the next, hopefully, hour or so. So don't really feel like you need to buy the book, because we're going to cover a lot of stuff in the next hour that'll get you started pretty quickly. Now, when we talk about reactive programming, it's important to sort of contextualize it. Why do we care about reactive programming? What is it about this thing about which the people in the Java ecosystem have been talking about for the last 5+ odd years that makes it so valuable today? Why not yesterday, right? And I think it's not hard to find reasons that motivate the use of reactive programming. We can look to the introduction of the iPhone and Android and all these different sort of clients that proliferate demand, that require us to be able to contend with that demand. That's certainly one factor. Another is that we now have the tools to be able to contend with that demand, but we find that those tools can be insufficient. Some of those tools are what I like to think of as stopgaps, and they have served us well, right? The ability to scale out horizontally, assuming we have microservices, on any commodity cloud infrastructure, is a great example of tools that allow us to, as a stopgap, scale out to meet that demand, right? I can put things behind a load balancer, and then assuming I have stateless microservices, I can very easily load balance across those different nodes. That makes it easy for me to scale. I've long had access to tools in the classic Netflixian sort of sense of the word to support cloud native data access, things like Cassandra, things like MongoDB. I hesitate to use MongoDB in the same idea, in the same sort of scenarios as you might Cassandra, but certainly you'll be able to scale there, right? So we've had a lot of great things that allow us to get to scale. But the question then, of course, becomes, wait, why do we need to scale so quickly? What is it? What's the threshold at which point we decide to add more instances to the load balancer rotation? Why not just make our individual services more capable, more efficient? And for a lot of people, the saturation point isn't immediately obvious. What people don't seem to appreciate is that it's not a matter of RAM or CPU. It's really how many threads can you run on the JVM today in 2020, early Q1 2020. The JVM it has a sort of a poor ability to add more threads, and that's because those threads are backed by operating system threads. Operating system threads are expensive, and so what we want to do is make it easier to repurpose threads that we have rather than create new ones, because creating new ones in perpetuity is not a scalable strategy. It's not practical. Now it'll be eventually more practical, but even then it denies us of another thing which we're going to need as we start to scale out, which is better tools and primitives for building coordination between services and systems. How do we describe a world where we might have potentially unlimited amounts of data, potentially latent data, potentially flaky data where services with which we're interacting might fail? How do we handle that? How do we build software that adopts accordingly? And so that, my friends, is what we're going to talk about today. We're going to talk about how reactive programming facilitates those use cases. Now, reactive programming is a nice, big, abstract idea, but what we need to fundamentally understand is that it's all about writing code in such a way as to give the system a sense of when we are done with a thread. What would keep us on a thread? Well, whatever keeps us on a thread, we say is blocking. Things like CPU bound activities, like the Fibonacci series, which is an algorithm. Things like cryptography, right? Things like Slack pegs the CPU, just terrible for CPUs. So you don't want to run any of those if you can avoid it in a reactive application. There are other things that also block threads, such as the traditional approach to doing input and output, Java I/O input stream and output stream. This is I think the main offender, actually. Java I/O input stream is a way to do input and output on the JVM, and it's been there since Java 1.0, and it provides us a simplistic, albeit not particularly helpful API for working with this idea of streams of data, right? Byte streams of data. This interface, this very simple contract is very simple. You say, hey, input stream, I'd like a new byte, and you say .read, and then you wait. You, the calling thread, sit there and you're just waiting. You're idle. You're just sitting there checking your clock, waiting for the next byte to arrive. That's a problem because that thread could be doing something else in the meantime, and you don't know when the next byte will be here. It might not ever get here, and this is why we have a whole bunch of sort of anti-patterns or patterns that I can appreciate the need for, but which in an ideal world wouldn't be so needed. Things like a circuit breaker or timeouts, right? Timeouts are a good example of something that we shouldn't really need. We should just be able to say, hey, I'm not interested anymore, right? Rather than having to throw up our hands in disgust and then tear down the thread violently as we do. So we want something that allows us to say, I want to deal with this data, but I want to do so only when it's here. In the meantime, I want to free up the threads that I was otherwise monopolizing for reuse in the system. And that's what reactive programming does. But in order to do that, you can see that we have to change the way we write code. We can no longer afford this sense that we can just, in a blocking fashion, wait for the next byte. Instead, we have to say, I'm interested in the next byte. When it's here, call me back. Give me an interrupt. And that's actually what's happening at the lowest levels in the operating system, my friends. We're actually letting the operating system babysit a bunch of file descriptors. And as soon as there's activity on any of those file descriptors, we get a callback. That's what we're doing in our Java code. Needless to say, this changes the paradigm. It changes the way we write code. So we need types. We need data types that allow us to work with data in this sort of inverted, asynchronous push versus pull sort of style. Enter the reactive stream specification, which is a set of types that were extracted out by a number of different organizations: Netflix, the Spring team at Pivotal, then now at VMware, and at Tanzu, and the Eclipse Foundation, and Lightbend, then called TypeSafe. So all these different organizations extracted out a common set of interfaces. These are common ground interfaces that allow us to describe asynchronous streams of data. This is called the reactive stream specification. And as you will see, they are really, really tiny. There's not a lot to them, but they work. Think of them kind of like discontiguous asynchronous Java arrays, on top of which Project Reactor from the Spring team builds in support for operations, operators, things that allow us to do things like mapping, flat mapping, filtering, etc. Things that allow us to operate on streams of data. All of this is super useful, but it's not yet enough to get to production. You see, these things don't give us the primitives we need to be able to build the daily bread and butter kind of software that drives our business. So we need to turn to things like Spring. Spring provides in Spring Framework 5, and later we have a net new reactive web runtime called Spring WebFlux. On top of that, we have Spring Data, Spring Security, Spring Boot, and Spring Cloud, and so many other projects besides that have all integrated reactive programming wherever appropriate and possible. And so now, today, as I talk to you in 2020, it's possible to build end-to-end reactive systems and services. And that, my friends, is the journey that we're going to walk right now. We're going to do that, of course, by going to my second favorite place on the internet, after production. Obviously, I love production. You should love production. You should go as early and often as possible. But if you can't get to production, or if you're not already in production, you can begin your journey there here at start.spring.io. So we're going to build a new application, and we have before us a number of different choices. I'm going to be content with most of the default selections. I'm going to go ahead and make sure to choose Maven and Java as my languages, though I encourage you to explore Groovy or Kotlin or Gradle if you like. We have the choice of version of Spring Boot. I'm going to use 2.30 M4 because hashtag YOLO. It has the latest and greatest support. It's fastest. It's got good support for a lot of other stuff that I want to use. But keep in mind, it's not yet GA. So, to each their own. Now, when I use 2.30 M4, one of the nice features I have here is I can automatically turn my Spring Boot application into a container by running it through a build pack that'll actually generate a container that you can then deploy to, for example, VMware's PKS, right? The Kubernetes distribution, or any other Kubernetes distribution, really. Now, having made those selections, I want to also give my application a name. I'm going to give it the imaginatively named application service. I'm going to choose .jar. I'm happy with that. I'm going to choose Java 14, which is the latest and greatest version of Java. Before you have 3 choices, but I encourage you to ignore Java 8. That's not really a choice, even though you see it there. Before you have 2 really valid options: Java 11, which is the current long-term supported version of Java, and Java 14, which is the current 6-month supported version of Java. I encourage you to use the latest and greatest version of Java whenever possible. Remember, most cloud platforms will automatically conveyor belt you to the next version anyway. And in the meantime, there's a lot of new features that make Java 14 very, very interesting. And for more on that, I encourage you to watch my Spring Tips video, Java 14, that I just did, 3 weeks ago. Here we go. Watch this if you can. It probably won't be the worst mistake you make. Okay, now we have a number of different choices. Again, Java 14, Java 11, good choices. These are both technically the correct choice as well as morally the correct choice. Again, do you want to see that look of despair and shame in your child's eyes if you explain to them that you're still running Java 8 in production? I don't think you do, my friends. I don't think you're ready for that particular conversation. So instead, do the right thing. Use the latest version of Java. It's good for you. It's good for production. Now, moving on. We're going to specify a few different dependencies. I want Lombok here. I want the reactive web support. I want R2DBC. I want, what else do I want? I want RSocket. And I want the, let's see, Postgres driver. I want that as well. And I'll even use MongoDB because it's awesome as well. So I'm going to bring in a number of different dependencies. I'm satisfied with my selection. So I'm going to hit Command Enter or generate, and that's going to give me a zip file, which I'll then open up in my IDE. And it doesn't all that much matter what IDE you use. Anything will work just fine. Let's make the font here bigger. Good. Alrighty. Now I have an application. Close that. Good. Now we have an application. In the application, waiting for the IDE to download the internet again. This is the thing you get for living on the edge as I do. Service. Alrighty. So we have our entry point public static void main. I'm going to talk to the application. I'm going to build an application in a number of different ways here. I'm going to talk to MongoDB at first. So I'm going to comment out R2DBC and PostgreSQL. Et voila. Good. I'm going to say enable auto import because I don't want to have to be prompted to change my build and to have that synchronize with the IDE yet again. And we're going to build an application. Now in my local MongoDB instance here, Mongo, I have a document. A document is I have a collection. A collection is a sort of like a table, and each record in a collection is called a document. So I'm going to delete that collection. You can see that I've deleted it there. I can delete it no more. And I'm going to create now a Java object called reservation. Let me make the font a little bit larger here, friends. I worry that you can't see that if you're streaming online. I've only got that at 20, so I'll make that 26. There we are. That's a little bit larger. Hopefully that suits all of you. Now, this is going to be an object at document using Spring Data. I'm going to map it to a document in Spring Data. It's going to have a field called an ID. It's going to have another field called name. This is going to be signaled as the ID by using the ID annotation. And that's the essence of what I want to express. But of course, this is Java. So I'm going to have to use getters and setters and toString and equals and hash code. And let's see, right? And I want constructors perhaps. Good. So look at that terrible code, nonsense, garbage code. Now, of course, in Java 14, if you're using preview features, which I could do, but I really have the time, you could use records. Or if you're using any other language at all, you could use something like case classes in Scala or data classes in Kotlin. But since I don't have time to do all that, I'm going to just use Lombok. Lombok's a compile time annotation processor that makes the work of creating these kinds of data classes much more precise. Now, I want to be able to save and manage instances of this type into the database. I'm going to create a reactive CRUD repository. A repository is a thing that manages the tedious, soul-annihilatingly boring data access lifecycle, data management lifecycle. So it's going to support common operations like saving all, finding by ID, checking if it exists, counting, deleting, etc. These operations are fairly straightforward. I'm sure you can gather by the signatures their basic essence and what they're supposed to support. That said, there are maybe a few types that are perhaps confusing. So let's go review some of these. The first and foremost of them is Publisher. A Publisher is a very simple interface that hails from the org Reactive Streams package, the aforementioned Reactive Streams specification. A publisher is the heart, the beating heart of anything you do that is reactive on the JVM ecosystem today. A publisher publishes data asynchronously out of band to a subscriber, which consumes it as each new record arrives in the onNext method. If there are any errors, when ineluctably there are any errors, you get to process them in the onError method. And when you're done processing the data, you have the onComplete method that gets called. Now, these are signals to you that you are supposed to act in response to events in the producer of the data. Now, what happens if that producer goes off the tracks? What if the producer gives you more data than you can handle? Well, my friends, this is where the real revelation of the Reactive Stream specification, the subscription, comes into play. You see, this subscription is what you're given when you first subscribe to a publisher. The subscription represents the state of the stream. It represents the link between you, the consumer, and it, the producer. It is the thing that you can use to request more or less of the data from the producer. You say, publisher, I would like to request 10 more records. I would like to request 100 more records, or any amount that you feel you can satisfactorily handle without being knocked down. So this is how you scale your services, is by making sure that you can't be overwhelmed. This is fundamentally just a very simple thing. It's called flow control. And if you've ever used any kind of network, done any kind of network programming at the lower levels, then you know that this is something with which you have to contend when you write basic TCP UDP code. It's not a new idea by any stretch. The insight here is that we've surfaced this as part of the top level API. The other thing you have to keep in mind is that you might sometimes hear a term called back pressure. Now, back pressure is a marketing term. It means flow control. It's nothing new. It's the same thing that we've had to contend with ever since one computer was on the same network as the other, since time immemorial, right? Flow control is back pressure. It just means, hey, I am not going to be overwhelmed by a producer. I'm going to control the rate of consumption, okay? This helps promote more stable services. So now we have seen the publisher, the subscriber, and the subscription. There's a fourth type in the Reactive Stream specification called processor, which is a bridge. It's a source and a sink. Now, these types are super useful, and you might argue, hey, if they're so useful, why aren't they in the JDK? To which I say, they are in the JDK, friends. They're actually type for type, interface method for interface method in these Java util concurrent flow type. So Java util concurrent flow, processor, subscription, subscriber, and publisher. Now, these types are there for you. They're interchangeable. There's even adapter types that you can use to convert one from the other, with the only difference being, of course, that the packages are different. If you're using Java 9 or later, you have access to these. If you're using Java 8 or later, you can use the Reactive Streams types. You're not going to be using Java 8. It's the wrong thing to do. We've already talked about that. So I encourage you to choose either one as quickly as you like, or as usefully as you want. Okay. Now we have our repository. We have this basic thing. Let's create some sample data. I'm going to write some sample data to the database. I'm going to create a Spring bean that just listens for an event when the application context starts up. And we're going to write some data to the database. And it's just going to be a chance for us to get some sample data into the database so we have something with which to work for our demo. Now, I want to inject this into the constructor. I could use a bean constructor like that, but instead I like to let Lombok do the heavy lifting here. So I'm going to ask it to create a constructor for any non-initialized final fields there. All right. Now, in order to create some data, I'm going to have a stream, a reactive stream of type Flux. Now, we didn't talk about this. These are two of the other types that you can get from that repository. The first is a Flux. A Flux is a specialization. It's a subtype of publisher. It is a publisher that produces 0 or n values, 0 to n values. We also have mono. Okay, so these two types, these two specializations come from Reactor, not from the Reactive Stream specification. A mono is also a publisher, but it produces at most one value. So when you see a mono, think, hey, that can only have one value. So it's kind of like a completable future or like an optional, okay? When you see Flux, think of that like a Java 8 stream, except these both support back pressure. Now, I'm going to create a Flux. I'm going to put some names in there, people on the Spring team. My name is Josh. It is so lovely to meet you. Who else should I mention that's on the Spring team? We've got Madura. She's a legend. We've got, who else is a legend on the Spring team? We've got Ria. She's awesome as well. We've got Yushin. She's amazing as well. We've got, Who else? Violetta, one of the best. We've got Dr. Sire. He's amazing as well. We've got Spencer and Stefan. Okay, Stefan with an accent. And voila, there we are. There's a bunch of names on the Spring team. Now, actually, I'm using Java auto typing there. I'm using the auto type inference, but I could have just as easily given it the full explicit type, but I tend to prefer that because it's easier to read. Now, I'm going to visit each one of these names and turn it into a new reservation like so. And that's going to give me a reactive stream of reservation. And what I want to do then is turn each one of those into a record that gets saved into the database. So I'll say this.reservation repository.save, passing in R. Now, when I say map, what does that do? It takes the result of the Lambda and accumulates the resulting value from the Lambda, the inner function reference. It accumulates that into a container type, in this case, another reactive stream. But the inner return value is a publisher. It's a reactive stream of reservation. So what I end up getting is a publisher of reservation. That's one publisher too many. So what I would like to do is to flatten that, right? Very much like the curves these days, it's important to flatten your reactive streams. And so what I'm going to do is I'm going to use flat map to flatten that nested inner reactive type. Now I have one reactive type called map1, and now if I were to run this code as is right now, nothing would happen. You see, this is a inert type. It doesn't do anything unless you subscribe. So you have to say subscribe. Okay, so I can say subscribe out, print line, etc. That's fine. Okay, system dot out. Okay, so I could do that. Now this is a lot of code. Let me clean this up. I don't like to have these variables sort of spaced out like that. Instead, I like to map these things together. Okay, good. And I can say names dot subscribe, and I can print it out. Now that's fine. That's much better. It's got one pipeline, right, with multiple steps. If I were to run this code right now, the result would be that I would have several different redundant copies of the data in the database. So what I actually want to do is I want to say, hey, first delete everything, and then return a reactive type. And then once that reactive type is asynchronously finished deleting everything, then and only then do I want to run the pipeline that's described in the 3 steps above. And then once that's asynchronously and reactively finished, then and only then I want to find all the records. And then finally, I want to print out the records as they arrive, as they trickle out from the database. So let's go ahead and do that. I'll run the code. I'll hit compile. I'll take some water. I think I've deserved it. Here we go. Oh, yeah. Good stuff. Okay. So now, if you look at the console here, you can see it worked. Of course, it worked. There's our names. Let's go get a name there. And we can say db, well, let's say db dot reservation dot find. Okay. Oops. Good. There we go. And we can see the name. We can see the ID reflected there from Adura. So it's obviously been persisted into the data store and it's working, right? And all this time I've been using a NoSQL data store that's MongoDB, but it's not the only option you have by any stretch, right? We have a number of different implementations, a lot of different Spring Data projects that you can use if you like, including but not limited to MongoDB, Couchbase, Neo4j, Redis, Cassandra, Elasticsearch, Google Cloud Spanner, Google Cloud Firestore, and Azure's Cosmos DB. All of these are well supported NoSQL data store options, but the question that we often get is, hey, what about SQL? Well, for this, we have built an abstraction called R2DBC. Now, R2DBC is the Relational Reactive Database Connectivity Abstraction, and it supports a number of different drivers, including Postgres, H2, MySQL. There's other ones by the community. There's a SQL Server, Microsoft SQL Server, etc., and the ecosystem at large. So these are core SPIs, and they work in Spring Boot naturally. So I can just uncomment this starter and comment out the MongoDB support here. And I'm going to bring in back the PostgreSQL driver as well. And with that in place, I can now talk to Postgres. Now I've got Postgres running on my local machine as well. So let's make sure this is happy. It looks like the build's unhappy for some reason. Why are you upset? Let's see. Okay, happy? Everybody happy? You know what? It is doing some weird thing. I'm just going to get rid of that. Good. Now, with that in place, I can change this code. You can see that the document annotation no longer applies. I'm using a PostgreSQL database table. So I have instead of a UUID, which is what I was using in MongoDB, I have a monotonically incrementing primary key. So I'm going to say integer ID. And for my primary key here, I'm going to signal that we have an integer as well. And that's basically it. That's the crux of the changes I need to make. Now, I grant you that this is a super trivial domain. So don't receive this as the idea that you can just use one any database you want with the same domain model, that's not going to work and it wouldn't be practical. But in this case, it happens to be trivial. So I've just restarted, and you can see that because I'm streaming on my computer and I don't actually have a dedicated streamer, that this is actually lagging. So, okay, we notice that there's a bit of a problem here. I've got some issue here. And the reason I've got this issue is because I have forgotten to specify a connection. So R2DBC URL, R2DBC Postgres, localhost orders, and username equals orders, and password equals orders. Now, don't tell anybody this very, very critical, very secret password. Don't ever do what I'm doing either. Don't encode usernames and passwords in your property file. All right, there we go. I restarted the application. You can see reflected in the output there are names. So if I go to PSQL here, Control C, PSQL U orders, and I say select all from reservation. And there we are. There we are. We're happy few. Okay, so it's worked. You can see Stefan has ID 7. Stefan has ID 7. Very good. So now we're talking to an SQL data store just like that. Now, I have data in the database. A common question might be, hey, suppose I wanted to do more coarse-grained operations like validation, or if I wanted to do something that required working in batches. In this case, you might want to support transactions. And for this, Spring provides the reactive transaction support. We have reactive transaction demarcation. And that's a whole other video. In fact, I've done a Spring tips video on just that topic. That abstraction supports transactions, logical transactions, wherever it's natively supported by the underlying reactive driver. So MongoDB, R2DBC, Neo4j are but a few of the different options that you can use today. It's the same abstraction. So you write the same code, you just change out the implementation of the reactive transaction manager. Okay, now I have data in the database. And a natural next question might be, hey, suppose I wanted to build an HTTP endpoint to be able to talk to my data, right? And that's no big deal. Reservation HTTP or reservation REST controller. Let's say, okay, I can do this the old-fashioned way. I can use a Spring MVC style endpoint like so, and return a publisher of reservation. And here I'm going to inject the reservation repository. So I'll say private reservation repository, and there we are. And I'm going to inject this into the constructor, and I'll return this.reservation repository find all. And there we are. There's my simple HTTP endpoint. I'm going to go ahead and restart the application, assuming I don't screw that up. Okay. Turns out you need to be able to compile your code for it to have any chance of succeeding. So run. Let's forestall my running a little bit here. Copy. Okay, good stuff. So now, if I go to the application, I can say, hey, reservations, 8080/reservations. There we are. We happy few, all 8 of us. I quite like that. I like the Spring MVC style. If you're familiar with this style, then it's not going to be too big a stretch to make the leap to this new world. This is a Spring MVC style endpoint, but it's actually not Spring MVC. We're using a brand new, net new reactive web runtime called Spring WebFlux, and there is no servlet API on the class path here. By default, we're using Netty, the super lightning fast asynchronous IO-centric IO driver. Okay. Now I like that style, but perhaps some of you are more familiar with things like Sinatra and Express.js and Scalatra and Spark Java and so on. In which case you might appreciate our functional reactive style, right? So router function, server response, and you can return routes. Okay. .build. Come on. My tool really wants to make this happen. HTTP router function .route. Good. Okay. And I can turn that into a static import. That's what I wanted in the first place. And now I can chain together a reservations endpoint handler function. And I can say I want to return a server response. So server response .ok.body. And here, my job is to inject the collaborating object, the reservation repository, RR, and then produce a response .find all reservation.class. Okay. Now, this is a bit verbose, but remember, this can be boiled down into lambdas and that into a static import. And what we get is just this one line to satisfy the same use case as I previously satisfied with that entire REST controller that we just built down here, all 6 or 7 lines of it. Now, again, it's a builder API, so I can chain together other endpoints here. And rather than having inline lambdas here, I can also use method references. So I can, essentially delegate to other objects and their implementations for that as well. Lots of things you could do. Okay, so if I restart that and visit the browser, assuming it compiles, it's literally taking more time to compile than it does to run. I love 2020. No, I don't. Here we go. There we go. Same data, same exact response, just as before, just a little bit more concise, my kind of thing. Now, I can hear you collectively shrugging and saying, so what, Josh? So what? It's 2020. You just showed us that we can return 8 records of JSON from an HTTP endpoint, and we can talk to a SQL data store. So what? I could have done that yesterday. Heck, I could have done that last decade. I don't need to change my reactive. I don't need to change to reactive in order to gain that. What did you just buy me? And you make a great point, but hear me out. What we've just done is we've established that there is parity here. Everything that you could have done before, you can do just as easily, if not more simply now. In fact, I would argue it's more simple. And the reason it's more simple, the reason it's simpler is because what you're doing today is using reactive types for everything. These reactive stream types are the new everything. They're one kind of stuff. And that means that things compose very nicely. So think about all the different APIs that you are familiar with that allow you to describe asynchronous streams of data, right? What kind of APIs am I talking about? Well, WebSockets, Kafka, data access code, service and events, right? RabbitMQ, JMS, anything really. So, anything that you can think of that you want to deal with asynchronously is now just a publisher, right? That means you have one kind of stuff. And so rather than learning different APIs for service and events, for Kafka, for RabbitMQ, for whatever, and to learn all the different control flow mechanisms and everything, now you've just got a publisher. When in doubt, use a publisher, right? It makes life much easier. And as a result, it is much easier to compose these different, otherwise disparate sort of streams of data. There's no glue code required because they all speak to each other naturally. Publishers, and in particular, Flux and Mono, because these are specializations that are designed to support composition, compose naturally, okay? So we have made things easier. I grant you that the upfront cost of learning a new type, of learning the reactive stream types, is going to be more considerable than any one of the upfront costs you might have had to otherwise deal with when you're dealing with things like Java collections or Kafka or RabbitMQ. But amortized across all the different possible applications of the reactive types, it's way easier to get going with reactive types, way easier, orders of magnitude. You are now in a much better position to just say, okay, I get it. Now let's integrate. Now let's actually pull together the right database drivers and message queue, connection factories and so on, and actually start writing the daily bread and butter software that helps us get to production. But that said, we're still not even really making great use of the features where reactive programming really comes into its own, that really are the wheelhouse of reactive programming. So let's talk about that. What are some use cases for which reactive programming is an ideal fit, something for which the old way is not only a poor choice, it's actually, in my humblest of opinions, akin to sort of programming malpractice, right? Because it would be bad for your production systems. Well, it's not hard to think of some of these examples, but first, a sip. It's not hard to think of some of these things. What we want to think of is anything where you might otherwise risk monopolizing a thread, anywhere you might otherwise risk keeping a thread open. And so think about the old world, think about the old way of working. Suppose you are building a chat system, okay? Hypothetical, very common example. You have a chat system and you want to make sure that all the connected clients get fast updates, right? So liveliness is the name of the game here. You want frequent updates, you want a frequent, liveliness here. You want good liveliness. So suppose you have a chat system, each client is connected to a socket and they're polling that socket. They're reading data from that socket. As soon as there's a new byte, they get the data and they use that to update their state on the local chat application. This is a very natural thing to do, but in the old way, keeping that socket open, which gives you a Java IO input stream, is also tantamount to keeping a thread open. So for every user that you add to the system, you have to create a new thread. This limits the number of users that you can have in your system to just, 1,000, if that, per node? You're not going to get very far at all in this way. So what you need to do is instead use reactive programming. This decouples the number of threads from the number of file descriptors. Remember, your operating system can handle a good deal, many more file descriptors than it can threads. Okay, so what we're going to do is we're going to create a service that produces an infinite stream of values, okay, every second. And so we're going to create a little greeting service, okay? And this service is going to return a stream of greeting responses, okay? So greet. And the request type is going to be a greetings request. It's going to be a service here. And we're going to create a DTO here, a type that'll just serve to convey the data across the wire. There we go. It's going to have a name. We're going to have another type here called a greetings request. So there's this, and we're going to have a message. All right. So the message here is just the thing that we're going to send back. The greetings response is going to have the name, the actual. Sorry, I got that wrong. Name and then message. So we send a name, we get message back, and there we are. Okay. So data at all orgs constructor, at no orgs constructor, and voila. There's my details. Now I'm going to actually implement this very simple service. In order to do that, I'm going to return a stream from a Java 8 Streams API, like so. New supplier. I'm going to return a new greetings response. I'm going to say hello request.name at, and then I'm going to provide a timestamp so that we can kind of see what and when. Okay, so instant.now dot exclamation mark. Okay, there we go. So there's my infinite stream. Let me turn it into a lambda. Good, and return that, and then close that off, and good stuff. Okay, now there's our reactive stream. I'm going to stagger the results of each output of each record by using delay elements. Delay elements has the benefit of introducing a bit of a delay so that when I scroll, when I print out the results, I don't have my console scroll right out the side of the screen and down onto the floor and out the door. Okay, what I have here now is a infinite stream of greetings, but it's going to be staggered by 1 second. I can do that. I can add time into the mix here because behind the scenes, the thing that moves the flow of execution of one reactive pipeline to the next, from one thread to the other, is a scheduler. And that scheduler is omnipresent. You don't really need to worry about it, but it's always there. And it's always making sure that your code is executing in the most efficient way possible. It's the thing that plays the worst game of Tetris you've ever seen with all the threads on the current JVM. And make sure that things are running efficiently. You don't really have to worry about it, but you can, if you want to, you can override it. For example, you can provide your own scheduler, as I have here, right? You can provide a scheduler that is adapted from a custom executor, right, etc. You don't need to do that though. By default, there's a scheduler that has 1 thread per core. Now, if you have a 4-core machine, then you only have 4 threads, and that's okay so long as you don't block any of those threads, as we described before. If you block those threads, then you are not just taking away the ability for 1 thread to provide 1 response to 1 client, you're taking away the ability for 1 thread to provide 25% of your client's response, okay? So you need to make sure that you do the right thing, that you quarantine, hey, there's that word again, or you isolate malbehaving or poorly behaving threads in a separate thread pool. And you make sure that those thread pools are not designed to be reactive, non-blocking thread pools. So we have a Java agent you can use called blockhound. You add it to the class path, and you say blockhound.install, and voila, Bob's your uncle. There you go. You get a stack trace whenever you call thread.sleep or you do anything else that otherwise blocks a thread. So if you start doing the Fibonacci series here, you'll get an error. It'll show you an error there, and so on. Okay, so that is a very convenient tool to help you ensure that you're not leaking thread resources in your system. So now I have this greeting service. In order to demonstrate this to you, I'm going to turn it into a WebSocket endpoint. So WebSocket Configuration. Okay, and I'm going to create a bean, simple URL handler mapping. This is going to be the thing that I'm going to use to map my HTTP endpoint to the WebSocket endpoint. So when a HTTP client connects to the application, they're going to connect to the HTTP endpoint called WS Greetings, and then we're going to do a handshake. I'm going to upgrade them to the WebSocket protocol. That's how WebSocket works. It's actually a upgrade protocol, right? So you upgrade from the HTTP protocol to WebSockets. So that's how I'm going to map it. I'm going to say, given a URL of WS Greetings, when somebody gets to that endpoint, give them a reference to the WebSocket protocol behavior that's described by this WebSocket handler. Now, we haven't actually implemented that particular functionality, so let's do that now. There's one other piece of infrastructure that we need to provide here. That's the WebSocket handler adapter. Okay, we return new WebSocket handler adapter. And now we're going to provide a WebSocket handler. Okay, WebSocket handler, and return a new WebSocket handler. And voila. Okay, there's our WebSocket handler. Now, this is the actual business logic. This is where the meat and potatoes of our implementation will live. It's a simple contract. When a client connects and establishes a new WebSocket session, we are given a pointer, a reference to that WebSocket session. In order to provide the business logic described by that WebSocket session, we're going to delegate to our greeting service, which I'll then inject there. And the job is very simple. When a WebSocket client sends, when they connect, they're going to send a name. We're going to say, hey, receive the name, map the name to a payload as text. And for each name, I'm going to take the name and turn it into a greetings request. Okay, name. And for each one of those, I'm going to call the greeting service. Okay, greeting service dot greet, passing in gr. Okay, and then for each one of those, I'm going to map the results, which is a greeting response. I'm going to turn it into text. And for each one of those responses, I'm going to map it and I'm going to turn it into a WebSocket text message. So session.textMessage text. Okay. And then for that whole thing, you know, break it apart in separate lines if you like. It might be easier for you to read, certainly is for me. And then for each one of those, I'm going to send it back in the chat. That's the whole pipeline right there. So there's my whole chat, if you will. One name in and a bunch of WebSocket messages out. And in order to send that back, I can just say session.send chat. Okay. So there's the entire pipeline. This is a Lambda, of course, that boils down to a Lambda. Very good, much cleaner, much easier to read. So that's the entire reactive application. Isn't that convenient? Now, in order to demonstrate this, I need a client of some sort. And if there were an easy way forward, if there was some way to do this with more aplomb and more dignity and more grace, I would do it. But I don't find that there is a way to do that. I don't see a way forward. So unfortunately, I need to do something that I don't like to do in polite company. But again, I see no more expedient path forward. I'm going to write JavaScript. So source main resources, static, create a new file, ws.html. And here, I'll create a body, and then inside there, I'll create a script, add event listener. When the document loads, I'll create a function that responds to it, okay? And in the document, oh dear, I got extra parentheses for free. I don't want extra ones, I want just the ones that I had. Okay, when that happens, I'm gonna create a WebSocket pointer, so WebSocket object, here we go, ws localhost 8080/ws greetings, ws.add event listener open, and when the open event happens, I'll respond accordingly by sending a message to the WebSocket. So send, and we'll use Tanzu. I was gonna use Bob, but you know what? Tanzu Tuesdays is much more fun. I mean, it's not more fun, it's just more apropos. Bob's here, Tanzu Tuesdays is here. Okay, so we've got open, and then when each message comes back, I'm gonna I'll listen for the message and I'll write it out, okay? Now, console.log message.data, there we are, okay? There's our simple JavaScript application. Let's go ahead and restart it and see what we get. Add some semicolons because that's optional because it's not a real language. Good. All right, restart. Now, localhost 8080 ws.html. Okay. If I go to the developer console there, you can see that it's going to stream out results every second in perpetuity, and that's okay. It's not going to block any threads on the server side. It's going to keep producing new values, but in between the raindrops, in between each new value, that thread is being freed up, and it's going to be reused by other things in the system. That's exactly what we want here. We want to be able to make better use of the existing resources. We want to be able to have our data center bill rather than make any one single per transaction faster, right? Per transaction, this is not faster. It might even be the same or even just a fractionally bit smaller, right? Slower. But we are able to handle more with this, and that's the real win here, okay? Now, we have an application. It's up and running. I like the application so far, but I also want to encourage you to think about some of the implications of using HTTP. Remember, HTTP is a very simple protocol. It gives you request response dynamics, right? In terms of the message exchange patterns that are supported, it only does request response. You make a request, you get a response. But you can't really do anything else. You can't do fire and forget, for example. There's no way for me to send a message and then have the server completely fail to provide, completely not provide any kind of response at all. It still has to set up the sometimes trivial response, even if it's just HTTP okay, right? If you're using anything below HTTP2, it's inefficient, right? It's very porous, it's text-based. It doesn't, even if you are using HTTP2, remember, HTTP2 is just pipeline. It's not actually multiplex, so you're not getting as much efficiency as you want out of that. It's not bidirectional by default, right? It doesn't support bidirectional communication. So it doesn't support a lot of the different kind of communication patterns that are very common when building sort of other kinds of applications. Also, consider that it's stateless, right? That means that each time an HTTP client makes a request, it gets a new response. this is inefficient. It means that each client has to create a network connection and ACK and disconnect and all that kind of stuff. It means that a lot of the overhead that we associate with microservice communication is actually because you're just wasting time setting up, doing the handshake before you're actually communicating every single time. So a lot of different organizations have created protocols and approaches to sort of get around or circumvent some of these considerable limitations. Google created gRPC. This is a nice choice if you can. If you don't mind the code generation and if you don't mind not having reactive APIs. It's made better by the Salesforce Protalk compiler plugin that supports Reactor-based services. So you can actually code generate Project Reactor-based services, which are then very naturally integrated into a Reactive Spring application because we're using Reactor here as well. Everything you've seen today is based on Reactor. That's one approach, I guess. It still requires you to do code generation and it requires you to describe your service in terms of the Google protobufs and so on, which is not particularly my cup of tea, but it does work. The other alternative would be to use something like RSocket. Now, RSocket is a protocol that was devised by engineers who worked at Facebook and at Netflix. This protocol was designed to support real production sort of scenarios. So it provides support for all the different message exchange patterns. It doesn't require any kind of code generation. It's payload agnostic, so you don't have to use Google Protocol Bus. You can use Protocol Bus, or you can use Avro or Thrift or Message Pack or JSON or XML or whatever, right? It just gets turned into bytes over the wire, so it doesn't care what it is. It has things like a header, right? Headers are very useful. Can't believe I have to say this, but how do you do, for example, security using WebSockets? There's no good answer because WebSockets don't have headers. So there's no way to transmit out-of-band information like an authentication token in that stream. So RSocket has that as well. And it's also production-minded. It supports production use cases, things like asking the service, hey, how busy are you? If you've ever used Spring Boot's actuator module, then you know that it's a very good idea to expose information that describes the health of the service to which you're making the connection. That's a very useful thing to do, but it's a Spring Bootism. It's nothing about HTTP. It's about Spring Boot, right? Wouldn't it be nice if you could trust that all HTTP services had an endpoint that we can use to ask them, hey, if I make a request, are you going to have a reasonable chance of being able to provide that response to me? Right now, if you know about Spring Boot, you know where the endpoints are mounted, great. But if not, you're just kind of on your own. Hashtag YOLO, I guess. RSocket provides that kind of metadata in the protocol itself. So it's a very production-minded, fast, super efficient approach to building services. And also, it can do a lot of things that you might otherwise associate with microservice sort of infrastructure, things like back pressure, right? Things like timeouts and rate limiting, all this stuff is all easily handled by the protocol. So what I'm going to do, my friends, is I'm going to turn our simple greeting service into a RSocket endpoint here. And the reason I can do this is because RSocket, the Java client for RSocket, and remember there are many. In the beginning there was a C++ one, a JavaScript one, and a Java one that were developed by Facebook, and Facebook naturally chose to build their client on top of Reactor. Okay, so it's a natural integration for us as well. So at message mapping, I'm going to give this a name, and that's it. That's the sum of the Java code changes I have to make. And now I can tell Spring Boot to start up the application on port 7070. I'll hit restart, and now I've got a service. I've got an HTTP service, and I've got an RSocket service. I'm going to go back to start that Spring Demo. I'm going to build a new application here. I'm going to call this one, artfully enough, the client. Okay, so there we go. I'm going to use Java 14. Sure. I'm going to bring in RSocket. And I'm going to bring in the reactive web support. And I'll bring in resilience for J just to show you that you can. That's a circuit breaker. And we're going to quickly build an API adapter layer. Okay, so here we are. Now, RSocket is super useful. Like I said, it's a very useful protocol. It can be used to do any number of different things that you might otherwise associate with things like a service mesh, right? If you want to do everything that Envoy does at twice the speed, use RSocket. Right, it's much faster, it's definitely more stable, and it's protocol agnostic. It does require you to change your code a little bit, but then again, if you want your services to be efficient, it's a fair thing to ask that your services be aware of how they're going to be more efficient. Okay, now let's see. We've got this up and running. Do we? No, it's unzipped it, but it didn't open it. Odd that. Pom.xml. Come on. IntelliJ is playing games. Let's just open it up directly. Okay, downloads, client, pom.xml, open as a project. Good stuff, open this up as well. Now this client application is going to run on a separate port. I'll say I want it to run on, let's say server port equals 9090. So there you go. And it's going to act as a HTTP client and as a RSocket client. So I'm going to create a simple endpoint that transforms the results that I get from the downstream service and represents them for the clients that are connecting to my edge service. So this edge service is a logical place for to act as the first port of call for requests coming in from the outside world, from my iPhones, from my PlayStations, my Xboxes, my HTML5, browser-based applications, etc. All these things will connect first to my edge service and then be routed to the otherwise fairly homogeneous downstream services. Here, I can adapt any incoming requests. I can handle things like authentication and routing and compression and all this stuff that's better handled here at the edge and then forwarded downstream. So what I'm going to do is I'm going to create an endpoint here, just a simple HTTP endpoint, an API adapter, and we're going to provide a simple view of the reservation service that we had before. Okay, so we're going to create a view that's just going to return just the names, nothing else, just the names, and enter. And there we go. So when somebody goes to /reservations/names, we're going to make a reactive HTTP call to the downstream service using the reactive web client. And here, remember, our HTTP doesn't know about reactive APIs. It doesn't know that you're using a reactive service on the server side. It doesn't care either. I can, let's see. Good. There, I can use a non-reactive client to talk to a reactive service, and I can use a reactive client to talk to a non-reactive service. As long as they're speaking HTTP, then it doesn't matter. And that's a bit of a bummer because remember, my reactive HTTP client, when it connects to a reactive HTTP service, the only thing it can do is disconnect. That's all. There's no way to just apply back pressure and not request anymore, and then just wait and then resume. Right? All you can do is disconnect, and then that can transitively, cause the other downstream reactive streams to start canceling themselves. Okay. With RSocket, you don't have that limitation. So here, I'm going to make a call to the downstream service using the reactive web client, which I'll inject here. I'm going to call that HTTP, and I'll make a call downstream, http.get.uri, http localhost 8080/orders, okay? And as the data comes back, I'm going to turn it into a reservation DTO. I'm going to take these types that I've got over here. I'm going to do something terrible, something that you should never ever do ever, not even when you're all by yourself and you're at home and no one is looking. I am going to copy and paste code. So there we are. There's my reservation. I'm going to create the greetings request and the greetings response. Okay, and voila. So there's this and this. Actually, I want Lombok. I do want those annotations here. What I want to do is bring back Lombok. Goody. Okay, there's Lombok. Now, with that in place, I can say enable auto import data. Good. Okay, one last one. And I don't need this. Okay, so this is my DTO types. Now, for the request to come back, it's going to come back as JSON. I'm going to turn it into a reactive stream, and then I'm going to map each one. I'm going to map each reservation into its constituent name, and that'll be the stream that I'm going to send back to the client, just a stream of names. It's a view on the data. This is a very natural thing to do. And you can see it's very natural to express that thing inside of an edge service like this. Now, let's suppose something goes wrong, okay? Something will eventually go wrong. How do I handle the errors? Well, I can say, okay, if there's an error of a legal argument exception.class, I can say, return flux.just eq, and I can downgrade, okay? I can also do timeouts. I can say, okay, do a timeout of 10 seconds, okay? I can also do a retry and a retry back off. I can say try 10 times and then back off, 1 second each time, right? Lots of things I could do there as well. Lots of different operators that you can use to make your code more robust. Another very useful thing you can do is actually use hedging, right? Hedging is this idea that you launch a bunch of calls in concurrence, and the first one that returns, you keep it, and you discard the other ones. This is great if you want to make sure that something responds within an SLA. This is a very natural thing to do here if you just use something like flux.first, okay? So it takes as many publishers as you want. and the first one to start emitting values, it'll just return that to you. Okay, so this is the HTTP endpoint, the HTTP client, but we have an RSocket service as well. So let's go ahead and quickly create an RSocket endpoint. So greetings name, okay, and we're going to create a service and event based on the parameter that you've given us. So request.path variable name. And there's a string name. And then from there, I'm going to use an RSocket requester. This is a bit like the web client there. It's the RSocket client, if you will. But remember, in RSocket, we don't have clients because there's no such thing as client and service. Once they're connected, both sides can initiate the discussion or respond to the discussion. So we're going to create an RSocket connection. It's going to connect on startup, right? We stay connected for the life of the application. So localhost, and we said 9090, right? So 9090. And there's our basic RSocket requester. And now we can actually integrate that here. So RSocket requester, RSocket, good. RSocket requester dot route. And the endpoint that we described earlier was called greetings. The data that we're going to send in is a new greeting request. And the greeting request will be Tanzu, okay? And the data that I expect back is a greetings response, like so. And that's going to be a never-ending stream, right? We saw that earlier. It's a never-ending stream when I did it with WebSockets. It'll still be a never-ending stream here. So what I'm going to do is I'm going to send back a service and event stream. I could have done WebSockets. I could have done something else. Service and events are HTTP, but actually I have a parameter here. I could have used the name. There you go. Service and events are HTTP based. The only thing you have to understand is that the client is going to see it's going to see that you're doing service and events, and it's not going to disconnect. So it'll just keep polling for the new data. Okay. So response will be a greetings response dot class, and the only other thing we need is a content type, which is media type dot text event stream. Okay, that's the only thing that's different from what you've seen thus far. All right, my friends, there's our RSocket endpoint and our HTTP endpoint. Let's go ahead and spin this up and see that all works.
My friend Josh, 2 minutes.
So we're down to less than 1 if everything goes
You're doing
swimmingly,
great.
but don't jinx it. Oh, okay, well, something's going great. Not me.
I'm leaving now.
Code. No, you're my good luck charm. Oh, you left and it's broken. Look at that.
Okay, I'm back.
No. Okay. No such thing.
Also, the trippy thing is I've actually never left.
No. Spring Application Admin Registrar. What in Sam Hill? That's a new error that I feel would probably not be a problem if I were on an older version of Java. So I will go down here. We'll just try it out. Project, Java 11, apply, go, do the thing, go faster, restart. Maven. Oh, you know what it might be? It might be this. Let's just get rid of that for now. Son of a gun. No qualifying bean. So what is that deal? Maven, re-import. Well, that's a bummer. Something's clearly wrong here. Spring Application Admin Registrar. What is that issue? It's in Spring Boot's auto-configured. Why do I have the auto-configuration for Spring Boot? Unsatisfied. No such bean of type environment available. Expecting 1 bean of that type. I feel like I've done my part to bring that application to life. Why is that? Let's see. Maven, re-import. Yeah, I don't see what the deal is. Oh well. Suffice it to say, this would be just fine if we were using. Oh wait a minute. You know what actually might work? Don't worry. I've got an idea. M3. When in doubt, roll back out. Okay. Could do. Fingers and eyes crossed. This is what you get for using milestones. This is my fault. I did this to myself. Santa Maria. Oh, good. Wait. 9090. Okay, connection refused. Is this running? Did I not run this? You need to run this in order for that to be successful. Okay. Is it on port 899? That's on 7070. And what did I say it had to be on here? 0. Client. $7070, friends. This is what you get for going too fast. I have the client to connect on port 7070, going to port 7070 over here. So this is up and running on port 7070. Here's the client. And voila. Okay, so there we go. So who's to say where the particular error was? I'll bet all that new stuff would have worked just fine. Let's just see it in action and then stick the dismount. Localhost. Localhost. We said 9090, right? That's the port on which this is running. 9090 / reservations / names. Oh, we don't know which port this is running on. This is running on port 50832. Yeah, okay, so good. Random port. And that's running on port 880, right? Client, reservation names, local host. Oh, reservations. Restart. Of course, that didn't work. And this is where the timeout would have been very useful if I was willing to wait for that time. Oh, different port now. This is my own fault. I did this to myself. 50, blah, blah, blah. Okay. There we go. There's the name. So that worked. Now, what about the RSocket endpoint? And we get that by going to greetings. Okay. So greetings, and then we pass in a name. And I'm going to use Bob the patient. Whoa. Oh, you, Bob.
Thank you for using my full name.
Yeah. Your given name.
You're doing great, by the way.
No, I'm not. That just blew up. That's a bummer. That's a bummer.
Oh, see, I jinxed it again. I came back on and I jinxed it again.
Get out, Bob.
Darn it, Bob. I want to give it one more shot here.
Yeah, man. We're enjoying watching you fix it.
I'm enjoying that. I'm not enjoying watching me fix it, but you know,
it's all learning.
I get the.
We're all learning.
It is. It's a bit. It's at least it's not production. Oh wait, this is production. Darn it. Okay, hold on. Wait for it. Okay, that seems happy. So it tells me that I could have run it the first time. Oh, the port has changed, hasn't it? It's changing each time because I used a random port. So here, no serializer. I want a refund. That should have been easy. What is the issue there? Oh, well, friends, try the code that I have got in that Git repository. That, I assure you, does work. It's not using the latest and greatest versions of Spring Boot, the milestones. And if I were a little bit wiser, I wouldn't either. I would be using the latest. I would be using the latest stable version. So 2.26.release. That would actually probably get me there. Let's see if that does anything different.
Hey, Josh, Spencer suggested
really
that
Spring
it could
Cloud.
be missing Lombok annotations on your response.
On my response, yes, Spencer for the win.
That's why he's the fifth Gibb brother. He's very talented.
Spencer Gibbs, Spring Cloud co-founder and legend. And by the way, this issue was just me. Let's try that. M4. Wait for it. Oh, see, I should have copied and pasted. This is the first time in my life where copying and pasting would have been better. The Jaws music is appropriate. Okay. Okay, 5107. Wait for it. Ha! Hooray! I'm gonna applaud for myself. That's okay if you don't want to. So there you go, my friends. We have now the never-ending stream of greetings from our service. All of that live with Spring Boot 2.30 M4. So that clearly works. And I'm getting back a reactive stream. I'm getting back a reactive response stream based on my call to the downstream RSocket call. So I've got an HTTP service and event endpoint, which in turn triggers a call to an RSocket endpoint, which in turn triggers a call to my greeting service. And I've got a reactive HTTP endpoint that triggers a call to my HTTP reactive reservation service. And along the way, we looked at a bunch of different patterns, like retry and timeout and so on. My friends, this is the real power, the real opportunity for building reactive applications on top of Spring, is this nice composition. The only thing, as we found out, is you need to spend just a slightly bit of time making sure that you actually type the right thing. I didn't do that today, hence I failed. You can do better. I know you can. I want to thank you so much for your time today. I know that you had a lot of places you could be, but you chose to hang out with us. So thank you so much for that.
Thank you, Josh, and thank you, Spencer Gibb, one more for that little team help. It's nice having some of the other Spring people on this, watching you and your work. This has been great. Everybody, Tanzu Tuesdays. This is going to happen every Tuesday, 1 p.m. Pacific time. We're excited. Josh, thank you again for kicking us off in wonderful fashion with this Spring Reactive. And I hope everybody, I hope everybody at home is healthy and safe. That we're getting through it. Everybody, just continue to stay home and taking care of yourselves and your families. If you want to learn more about Tanzu, you can always go to tanzu.vmware.com. And if you want to find Josh at Starbucks, man, if you want to put back up your you're appropriately giving Spencer Gibb his credit where credit is due. So yes, but yes, he is. He's a wonderful, wonderful man and a great father, and obviously an incredible developer as well. So thank you all for listening. I'm Bob Brindley, for Tiffany Jernigan, Paul Tchaikovsky, and the rest of the developer advocacy team, which Josh, of course, is a part of. We can't thank you enough. Next week, we're going to have Jakub Pileman on.
I'll be there.
He's great. He's going to be coming live from Poland, so I don't even know what time it is going to be for him, but it's still going to be 1 p.m. Pacific, our time, my time. I don't know where everybody else is in this world, this crazy world we live in. We did it, everybody. Thank you, Josh. Have a great week, everybody.
Stay safe, everybody. Stay at home.
We're just going to keep doing this until